Okay, so we've been talking about combustion in class, and what combustion is taking a fuel source, generally a hydrocarbon, something that generally is like a C2H6, whatever, and you mix it with oxygen and a spark, and what you get in return is a large amount of energy, with water and CO2 being your main components or your main products after the reaction occurs. So we've been talking about this. We've done some actual experimentation with combustion by burning our peanuts to see how much mass is lost. So today's demonstration is all about kind of getting into the nitty-gritty of this equation and what all of that kind of means in a practical sense. So I have several demonstrations for you today. So for these demonstrations, things we need to make sure we have. Safety equipment. Obviously, we're going to be dealing with flammable liquids. We want to make sure that we have non-flammable clothing on, or at least some protective layer on. On top of that, we need some sort of eye protection. In this particular instance, my glasses, being large, should serve well enough. And thirdly, what we need are the materials to actually conduct the lab, right? So we need a fuel source. So in this instance, for the first 3 demos, we'll be using ethanol. We need a graduated cylinder, 2 bottles, and some matches. And in regards to safety, once again, we have something here. Baking soda to easily put out any flames that could be caused by any ethanol spillage. Or if it's out of hand and gets too crazy, we have the fire blanket here. And the fire extinguisher is on the floor here next to me. So our bases are covered with open flame in this demonstration. So if any of you are thinking about trying this at home, please do not try this at home, because you can set things on a flame pretty quickly. So let's go on ahead and take a look. Other ingredients for the last 2 demos, for demo 4 and 5, we need sawdust and a piece of wood here from the exact same, it's the exact same wood that I cut this piece off with, that the sawdust is. So we have the same fuel source here, but in 2 different forms. And you'll see why that's relevant once we get to those demos. So today, what we're focused on first, the first 3 demos will be an alcohol demonstration. Let's go on ahead and go right into those. So, go on ahead and set my other bottle over here, get my safety stuff out of the way. I am going to take 1 milliliter, which is barely more than a few drops of ethanol. I'm going to measure it out appropriately. Okay, so if you guys can see on the camera, just the very first line of ethanol, and when I put that in this bottle, just like that, you can see there's almost no ethanol in that bottle. It's just a few drops. All right, so I'm going to do my magic plane and add some oxygen in here. This also helps vaporize the ethanol inside of the bottle, so I'm getting the ethanol vapors in here and evenly distributed with the oxygen in the bottle. All right, so with that, move my fuel source out of the way. I have the main ingredients we need for combustion. And again, those ingredients are our ethanol, C2H6O, I believe is the chemical formula. And we have our oxygen. And now we are going to add our spark. And just like that, you get a very clean and quick combustion process. Now, you can see that the bottle has been even further deformed. I have used this before for other demonstrations, and there's nothing left behind in the bottle. Okay, that was with 1 milliliter. Now, things we can adjust in the combustion equation. We can either adjust the amount of fuel that we have, or we can adjust the oxygen. other than spinning this around in the air, I don't really have any way of adding more oxygen, so let's add more fuel and see what happens. This time I'm going to take 5 milliliters of ethanol. Okay. Fuel source out of the way. 5 milliliters of fuel. And now for the oxygen. Okay, so we got our oxygen, our fuel source, and now we need to create a spark to get water, CO2, and energy. Now, as you can see, the result this time around wasn't quite the same as the first time around. And in fact, you can see some flame actually ended up inside of the bottle and melted this a bit and continued to burn inside. So that's one thing to keep in mind. The other thing to keep in mind is, as you can see, there's some residual liquid in here. And if I measure that out, it comes out to be about 2.5 milliliters. And what we would assume this either is leftover ethanol, which is what it smells like, or water if the water didn't evaporate. To me, this smells like leftover ethanol. And one easy way to find out, don't try this at home. This is a stone table specifically made for science experiments, so that it will not be damaged in what I'm about to do here. Also, again, safety equipment, safety equipment, safety equipment, so our bases are covered. If there is any leftover ethanol, we should see this ignite. Aha! So what we see here is only about half of our fuel ignited in our most recent experiment with 5 times more ethanol. Now, extinguish my flame here. Safety. Okay, so that was demo number 2. And from demo number 1, I added 1 milliliter of fuel. You saw a very real effect with that bottle moving across the countertop. Then I did it again, but this time I added 5 milliliters of fuel. Same amount of oxygen, or at least what I could do to the best of my abilities, get the same amount of oxygen in the bottle. And you notice this last time we had 2.5 milliliters of fuel left over that went unburnt. So what I'm going to do this time, as you can see, our bottles are starting to be a little bit deformed from our experimentation. What I'm going to do this time is add that same 5 milliliters, but instead of making sure I get it primed and get air in there and try and get some of the alcohol to evaporate, I'm simply just going to light it and see what happens. Okay. 5 milliliters of fuel. For the demonstration number 3. So what should have been very readily apparent in this one is we didn't get a lot of combustion. So the question is, between those 3 demonstrations, one where I used 1 milliliter of fuel, one where I used 5, and another one where I used 5, but I didn't shake it. I didn't do this number, I just lit it. What is going on here? Why did I get a very different reaction or a different scenario in each case? I want you to explain this beyond, oh, well, I added more fuel or whatever. Really get down to the nitty-gritty and explain to me, well, in that second demo versus the first one, yeah, I added more fuel, but what did you observe happen, and how is that significant to this equation? go back to this equation and think about these three demos. Well, what's going on here? Explain what happened, okay? So that's what I want you guys to do for the first part of this demonstration. Now, for the second one, moving on, so to speak. I'll get my matchsticks out of the way. Again, back with combustion and the combustion equation. I have one substance in two forms right here. I have a piece of wood, just some plywood that I've been making birdhouses with my students with. And then I have the sawdust created from cutting this exact board. So these two substances are chemically identical. However, they are structurally different. And what we're going to find out is just how different. So, to start with, think about let's make some predictions. We have a powdery substance here of wood, and you can see there's all these, it's basically little tiny bits and grains and shavings of that wood. And then we have a solid piece of that wood, very tough. Generally, we think about wood, not so easy to light on fire, right? So let's think about this. Which one do you think, based on this equation here and your previous experiences, which one do you think is going to light more easily? What do you predict is going to happen here? With that pause, let's find out. So we're going to count the number of matches. There's not a great way to kind of calculate how much energy I'm putting into this particular piece of wood. So we're just going to kind of count how many matches it takes for me to light this one piece of stick. And you know, to be scientifically accurate, or not accurate, but, you know, embrace the scientific method a little bit, we'll start off with a fresh, unburnt piece of wood. And just like that, didn't even need to use an entire match. I've already got a flame on this piece of plyboard. All right, so keep that in mind. I think I used maybe an eighth of a match here. Okay. Now, let's go on ahead and see how easy it is to light this match dust. Now, this sawdust. Now, let's go back to this equation real quick. Okay, I keep alluding to this because that's where the magic is happening right here. You see this, and the only thing we can adjust is the amount of fuel and the amount of oxygen something has. Well, that means you need to take a look at the structure of this sawdust. Which one of these is going to be either able to add more fuel or more oxygen to the equation, and why do you think that? Maybe you're right, maybe you're wrong. We're about to find out right now. As you can see, I'm able to get a flame. Used up an entire match already. But I'm able to get a flame when the match is there, but as soon as I take it away, the flame pretty much goes out. And what you can see now is this sawdust is just sitting here smoldering. So let me try it again. Match number 2. And it gets tape. And it's going to my little flame. Yeah, take this away, and I've got, I got a little flame started, but once again it's out. So here's a situation. In all 5 of these demonstrations, you've had the exact same amount or same types of fuel. In the first 3, we only used ethanol. And the last 2, we only used this particular type of wood. And yet in all 5 instances, we got completely different results. So what your job is now is to figure out what's going on here. Why does the sawdust continue to smolder, but it will not actually give off a flame? There's some heat here still. there's no heat coming off of this wood anymore, which means somehow maybe combustion is still occurring, but at a very slow rate. So again, to keep this academic and to keep this in chemistry, let's focus again. All of your explanations need to come back to this equation. Okay? So with that, I'm going to put out this smoldering pile of sawdust, and I'll catch you guys later.